Question number one. Question number one said an electron enters perpendicular perpendicularly into a uniform magnetic field, okay, uniform magnetic field which has a flux density of 0.2 Tesla. You stop. Okay, then I said this results in a magnetic force of 9.6 times 10 raised power minus 12 Newton on the electron. Okay, then I said calculate the speed of the electron as it enters the magnetic field. Okay, as it enters the magnetic field. Now, solution. First thing we bring out is our parameters. The first thing they gave us is what? Our B. Don't forget that your B is measured in Tesla. That is 0.2 Tesla. Okay. Now, the next thing they gave us is force. They gave us force. The force they gave us is 9.6 times 10 raised power what? Minus 12 Newton. The next thing they gave us is what? Is charge. Okay. Because they said it's an electron. So charge of electron is a constant. I think it's a 1.6 times 10 raised power what? Charge of electron is 1.6 times 10 raised to power what? Can you remind me? I think 13 or I don't remember. It's a constant, you need to know it. Okay. Charge of electron 1.6 times 10 raised power 19 minus 19, I guess. Minus 19. But let me be very sure. Let's check. Okay, let me use this. These are constants that you need to know. Oh, let me check from this book. Yes, 1.6 times 10 power minus 19, correct. Okay, so if we have that this is the charge, then what formula do you use now? They say we should calculate V. Our V is unknown, but I know that my F is equal to what? QVB sine theta. Okay, then my theta is 90. Don't forget, my theta is 90. So I'm going to get the maximum force here. Okay, don't forget that if it is perpendicular, your angle is 90, then you're going to get the maximum force. So my answer here is going to be what? My Q they gave me is what? 1.6 times 10 raised power minus 19 times. Okay, they gave us force. Okay, if I make V subject, my V will now be what? F over what? QB sine theta, which is what? My F is going to be 9.6 times 10 raised power minus 12 divided by my charge is 1.6 times 10 raised power minus 19 times my B is 0.2. So if I do this, I'm going to have 9.6 divided by 1.6 divided by 0.2. So I'm having 30. So this is 30 times 10 raised power minus 12 plus 19 will give you what? That is for the 10 is what? Minus 12 minus into minus 19 according to indices. So this is 30 times 10 raised to power uh, so I'm going to have minus 12, 19 minus 12. So I'm having 7 times 10 raised to power 7. So this is what? 3.0 times 10 raised to power what? 8 in what? In meter per second. So this is very, very simple to calculate. Move over to the next question. Question number 2. So question number two said an electron projected projected at an angle 50 degrees to a magnetic field of flux density 15 Tesla. Then I say it moves if it moves with a velocity of 7.0 times 10 raised to power 7 meter per second, comma, then I say calculate the magnitude of the force. Calculate the magnitude of the force exerted on it. Okay, solution. This is very, very simple. Let's get our parameters. Our theta they gave us is what? 50 degrees. Okay, our B they gave us is what? 15 Tesla. Okay, then the velocity they gave me is what? 7.0 times 10 raised to power 7 meter per second. So they say we should calculate our force. They say that an electron, immediately it is electron, know that the charge of electron is 1.6 times 10 raised to power minus 19 coulomb. Okay, I know that my F is equal to what? QVB sine theta, which is going to be what? 1.6 times 10 raised to power minus 19 times my V is 7.0 times 10 raised to power 7 times my B is 15 times what? Sine 50. Okay, so this is going to be 1.6 times 7 times 15 times sine 50. Sine 50. Okay, I have 128.695. Okay, 128.7. Let me use 128.7. Then times 10 raised to power minus 19 plus 7 according to indices. So I'm going to be having 128.7 times 10 raised to power minus 12. So if this move 1, 2, I'm going to have 1.28 times 1.287 times 10 raised to power what? Add 2, 1, 2. That is 10. Okay, in what? In Newton. So that is that for that. We move to the third question. Question number 3. The third question said uh, an electron entered a magnetic field strength or flux density 0.1 Tesla, okay, parallel to the direction of the field at 1.0 times 10 raised to power 7 meter per second. Calculate the magnitude of the magnetic force acting on the electron. Now solution. Now if you look at this, immediately you see parallel, it means that your theta is 0. And if your theta is 0, it has spoiled everything. Everything is 0 because my F is equal to what? QVB sine theta, and sine 0 is 0. Q times V times B times sine 0. Sine 0 is 0, which is what? Q times V times B times 0. So everything is giving me what? 0 Newton. So I don't need to calculate anything. Once it is parallel, it's giving us 0. So we'll go to question number 4. So question number 4. Question number 4 said a charge of 1.6 times 10 raised to power minus 19 coulomb. This is a proton enters a magnetic field of log density 2 Tesla with a velocity of 3 times 10 raised to power 7 meter per second in the direction at right angle to the field. At right angle to the field. Then I say calculate the force on the charge. Solution. So this is very, very simple. So they gave us the charge. The charge they gave us is 1.6 times 10 raised to power what? Minus 19 coulomb. So they gave us our B. Our B is 2T. And they gave us our V. The V they gave us is what? 3 times 10 raised to power 7 in meter per second. And our theta is right angle, which is 90. So what do we have? We now have that our F is equal to what? QVB sine theta, which is equal to what? 1.6 times 10 raised to power what? Minus 19 times 3 times 10 raised to power 7 times 2 times sine 90. So do that and then you get the results. Sine 90 is already 1. So I have 1.6 times 3 times 2. So I'm having 9.6. So I have 9.6 times 10 raised to power. If you remove 7 here, I'm going to have minus 12 in Newton. So that is that. We move over to the next question, question number 5. We're going to solve just 10 questions. So question number 5 said that an electron moves with a speed of 2.0 times 10 raised to power 7 meter per second in an orbit in a uniform magnetic field of 1.2 times 10 raised to power minus 3t. Then I say calculate the radius of the orbit. Okay, solution. This one is equally very simple. So what do we do? Let's get our parameter. They gave us our V is equal to 2.0 times 10 raised to power 7. Okay, they gave us our B as 1.2 times 10 raised to power minus 3t. What else they give us? An electron. So our Q is 1.6 times 10 raised to power minus 19 coulomb. Okay, we know that our F is equal to what? mv squared over r. Don't forget this, which is equal to what? QVB. Okay, we know this. So if you make our r subject, our r is going to be what? mv over what? QB. Okay, because one of these we cancel one of these. So this one going here, this one coming here. So I have mov over QB. So the mass of an electron. Yes, you need to know mass of an electron. And mass of an electron is can I remember? Yes, mass of an electron is 9.1 times 10 raised power minus 31. Okay? Yes, mass of an electron. Mass of an electron is 9.1 times 10 raised power minus. Okay, they gave it to us in the question set. Minus 31 kg. So if you put it here, you are going to have that 9.1 times 10 raised power minus 31 times the V they gave us is 2.0 times 10 raised power 7 divided by 1.6 times 10 raised power minus 19 times the B they gave us 1.2 times 10 raised power what? Minus 3. So if you do that, you're going to have 9.1 times 2.0 times, sorry, divided by 1.6 divided by 1.2. So I'm going to have 9.5 times 10 raised power. I'm going to have minus 31 plus 7 plus 19 plus 3. So I'm going to have minus 2 in what? In meters. So if you do this, it's going to be 0.095 meters. So that is that for that. Very, very simple question. So go to the next question, question number 6. I told you we have just 10 questions to solve. So question number 6. So question number 6 said a proton of mass, okay? They said that the mass we are going to use here is 1.7 times 10 raised power minus 27 kg. That is the mass of this particular proton. For the other one, they gave us the mass, so they are the one that gave us that mass. So enters a magnetic field as it is moving vertically, upward with energy 4.3 times 10 raised power 6 electron, okay, electron volts, okay. Then I say the if the magnetic field of 2t moving from east to west, then we should calculate I, the velocity with which the proton enters the magnetic field. Okay. Now I said that what the force on the proton, I the direction of the initial force. Okay, the direction of the initial force. So this is very, very simple to calculate. So what do? Let us bring out our parameters. That is the first thing you always do. Bring out your parameters. So I'm going to have, okay, solution. Now, the first thing they gave us is mass. They gave us that the mass is 1.7 times 10 raised power minus 27 kg. The next thing they gave us is, okay, they said that the energy, is 2.3 times 10 raised to power 6 electron volts. So the energy is what? 4.3 times 10 raised to power 6 electron volts. Okay. electron volt. Okay, so I'm going to have, what else they give us? They gave us our B. Our B is equal to what? 2T. Okay. So then I say we should calculate our what? We should calculate what they say we should calculate. Okay, calculate the velocity. Solution. Okay, I know that energy is equal to half mv squared. Okay, and the energy they give us is 4.3 times 10 raised to the power 6 electron volts. So you're going to multiply the electron with the volt to get the the energy. So the energy here is going to be what? This 4.3 times 10 raised to the power 6 times the electron. The electron there, this electron, that's the charge. The charge of an electron is 1.6 times 10 raised to the power what? Minus 19. Okay, is equal to that half mv squared. Okay, so if you do that, you're going to have, okay, let me put everybody. Half times my M they gave us is 1.7 times 10 raised to the power minus 27, then times v squared. So if you do everything, you're going to have that v squared is equal to what? 4.3 times 10 raised to the power 6 times 1.6 times 10 raised to the power minus 19 times 2, then divided by 1.7 times 10 raised to the power minus 27. So if you do that, I'm going to have 4.3 times 1.6 times 2, then divided by 1.7. Okay, I'm having 9.61. Okay, 9.61 times 10 raised power. This is 6 minus 19 plus 27. So which is giving me 14. Okay, so v is going to be the square root of that. So the square root of that 9.61 times 10 raised power what? 14. So okay, times 10 raised to power 14. Okay, then square root of that, my answer will give me 3.1 times 10 raised to power. This is 1, 2, 3, 4, 5, 6, 7 times 10 raised to power 7 meter per second. Okay, so we'll go to the next question. They say we should find the force on the proton. The force on the proton, we know that is II. Okay, the force on the proton, we know that F is equal to what? QVB, which is equal to what? My Q is 1.6 times 10 raised to power what? Minus 19 times my V. I've gotten the velocity as 3.1 times 10 raised to power 7 times the B they gave us is 2. So if you do that, you are going to have this is times 1.6 times 2, then times 10 raised to power minus 19. So I'm going to have 9.92 times 10 raised to power what? Minus 12 Newton. Okay. So the next thing they say we should calculate the direction. So the direction of the proton, the initial direction of the proton, that is the direction of the charge. I told you that, okay, direction of the proton. They told us that the magnetic field is moving where? Is moving upward. Okay, sorry. They say if the magnetic field is moving from east to west, so the magnetic field is moving, this is my cardinal point, north, south, east, west. So okay, the magnetic field is moving like this. Okay, is moving like this. So if it is moving like this, if it's moving like this, then therefore my current is moving upward. If it's moving like this, from what? East to west. It's moving from east to west, east to west. Then the proton, the proton is, I thought the thing they said that is that the direction is south. You see that direction is south, but I was thinking it's going to be north because I'm going to have the direction of my charge to be standing like this. Then my hand is moving from east to west, from east to west. Because if it is like this, it's going to be from east to west. But if it is like this, it's going to be from west to east. So I was thinking it's got less. Maybe if it's an electron, my answer is not anyway. So I don't know. You can find out yourself. You can type it and then research that if the magnetic field is moving from east to west, then where should be the proton, the charge on the proton? Where will it move? So you can make research on that to know where the direction should be. Okay, you should not confuse my life. So let's go to the next question. Question number question number whatever. Question number 7, okay? Question number 7 say that an electron an electron is projected an electron is projected into into a magnetic is projected into a magnetic field, okay, of 1.5 Weber per meter square. Weber per meter square with okay with speed of 2.1 times 10 raised to power 7 meter per second. You now say calculate the electric field E, okay, required to balance the force exerted on the electron by the magnetic field assuming electron entered at 90 degrees to the B field. Okay. Solution. Oh, all right. Solution. I know that the electric force F is equal to what? QE, right? And the magnetic force is going to be what? QVB. So what are they asking us? They say we should calculate our E. So our if Q take care of Q, then our E is equal to what? VB. So which is what? My V is what? 2.1 times 10 raised to power 7 times my B. My B is 1.5. So what are we going to have? So if you do that, you're going to have, then the angle is 90. So sine 90 is 1. So that's why I'm not using it. Put sine 90 is 1. So I'm going to have that is going to be 2.1 times 1.5. That is 3.15. So that is 3.15 times 10 raised to power what? 7. Okay. That is your E. Uh, Volt per meter. I use volt per meter. Our E is equal to what? Newton per coulomb. Anyone you like. Number 8. We're almost done with the calculation. Number 8. Number 8 said find the magnitude of the magnetic force on a 100 meter length 100-meter length of wire, okay, strung between two poles, okay, carrying a current of 250 ampere. Then I say the earth's magnetic field makes an angle 60 degrees with the wire. Okay, and then I say that B is equal to what? 5 times 10 raised to power minus 5t. Solution. Now, parameters, what did they give us? They said that they gave us L. Our L is equal to 100 meter. Okay, they gave us our current. Our current is equal to what? 250 ampere. Okay, what else they give us? They gave us our B. B is equal to what? 5 times 10 raised to power minus 5t. Okay, but I know that my F is equal to Li. I used to remember it with Li. So which is what? 100 times 250 times 5 times 10 raised to power minus 5. So the force, okay, leave sine 60. So I have sine 60. Okay, so do that. You have 100 times 250 times 5 times 10 raised to power minus 5. Okay, times sine 60. So I'm going to have 1.08 Newton. 1.08 Newton. Right? Very simple. We move to the next question. Question number 9. We're almost done. Said I'm going to solve just 10 questions. So, question number 9. Question number 9 said the field, magnetic field B over a certain region is 4I minus 11J measured in T, comma. Then I say an electron moving in the field with a velocity of v, which is equal to what? Minus 2I plus 3j minus 7k in meter per second. Then I say what is the magnetic force? Okay, what is the magnetic force? All right, now solution. Let's bring our parameters. They gave us our B. They gave us is what? 4I minus 11J plus 0K. Make it complete, please. Plus 0K in T. Okay, and they gave us our V as minus 2I plus 3J minus 7K in what? In meter per second. Okay, what did they give us? They said it's an electron, so they gave us charge. The charge they gave us is 1.6 times 10 raised to power minus 19 coulomb. Okay, but we know that our F is equal to what? Q in bracket of what? V cross B. All right, don't forget. So this is equal to what? 1.6 times 10 raised to power what? Minus 19. Then you now have your cross product, that is plus I minus J plus K. Okay, I'm going to have my V. My V is minus 2, 3, and minus 7. Then I'm having my B, 4, minus 11, and 0. Okay, so now let us get that. So I'm having that this is equal to 1.6 times 10 raised to power minus 19. Okay, in bracket of, don't forget, all these people are for picking. Go and watch my video on vector analysis. If I pick this person, I'm going to do cross multiply. I'm picking, okay, let me have this like this. I'm picking plus I will now open bracket left, right. This time this is 0 minus, this time this will give you 77. You close. Okay, the next person I'm picking is minus J. If I pick minus j, I will cover everybody under him. I picked plus I, cover everybody under him. So I'm left with 1, 2, 3, 4. I will do left minus right. This time this 0 minus this time this. You have this. Okay. The same thing again. If I pick this person, cover everybody here. I am left with 1, 2, 3, 4 because everybody on top is just for picking. So I have cross multiply again. This time this is what? 0 minus. This time this will give you minus 28. Okay. So minus minus will now make this place plus. Right. So finally, what am I picking? Finally, I'm picking plus k. If I pick plus k, I'm covering these people. I'll do left minus right. This time this will give you 22 minus. This time this will give you 12. So I have that. So my final answer is now my f is equal to what? You know, f is a vector quantity. So I'm going to have 1.6 times 10 raised to power minus 19 in bracket of, what do I have? This is minus 7, minus 77i. Okay. This one is giving me minus 28j. This one is giving me 10 plus 10k plus 10k. So that is that for that. You can decide to use 1.6 to multiply everybody. So let us do that. 77 times 1.6. So I'm going to have, this is going to be 123.2i with minus. Okay. Then 1.6 times 28. So I'm having minus 44.8j. Then 1.6 times 10 to give you 16. That is plus 16k. Everybody, you have 10 raised power what? Minus 19 in Newton. So that is that for that. Very simple. So we move to the next question, and which is the last question. The next question is the last question. So the next question said, question number 10 said that an electron experiences a force 3.2i minus 2.7j, then all times 10 raised to power minus 13 Newton when when passing when passing through when passing through a magnetic force B, which is equal to what? 0.72 k kt. Okay, 0.72 kt. Okay, then I say what is the velocity of the electron? Okay, solution. Now, solving this to bring out our parameters again. They gave us our force, our F, they gave us is what? 3.2i minus 2.7j plus 0k. You have to make it complete. All in Newton. They gave us our B, which is 0i plus 0j, then plus 0.72k. Everybody in T. You have to make it complete. Okay? So the next thing they gave us is our Q. They gave us our Q as 1.6 times 10 raised to power what? Minus 19 coulomb. Then they say we should find our V. So, but I know that my F is equal to what? Q in bracket of V cross B. Right? So, what do we have now? First of all, can we get V cross B? I want to get V cross B, then compare. Let me get V cross B somewhere. All right. My V cross B, please watch what I'm doing. My V cross B, they did not give me V. So, but my V like this, my V should be what? Let me say, do I call it IJK? Okay, let me call it V for I plus V for J, then plus V for K. Something like this. Or do I use XYZ that represent it? Let me use XYZ to represent it. So I have XI plus what? YJ plus what? ZK. So let me put it. So my V, so I have my plus I minus J, then plus K. Okay. Then I have my what? X, Y, Z. Then I have my B. My B is 0, 0, and 0.72. So if I do that, I'm going to have, I'm picking my plus I. I pick my plus I cover these people. I'm having left minus right. This time this will give you 0.722y. Okay, this time this will give you 0, right? Plus, pick minus j. If I pick minus j, I am left with, this time this will give you 0.72x. This time this will give you minus 0. Okay, I'm picking the last one plus k. I'm going to have, if I cover this, I'm going to have 0, 0, 0 plus 0. So I'm left with what? This time this will give you 0.72yi minus 0.72xj, then plus 0k. Okay, now that is what I got as my xv. So if I put my force, let me put my force. My force is giving me 32i minus 2.7j plus 0k. Okay, is equal to what? My q is 1.6 times 10 raised to power minus 19 in bracket of, I have gotten these people as, I've gotten this people as 0.72 yi minus what? 0.72 xj plus 0k. Okay, so now you have to use this and multiply this. You have to clear the bracket, then start comparing. Okay, but if you don't want to clear the bracket and compare, you are going to have that your, let's compare, this should be equal to this. All right. I don't know how I'm going to make you understand this. This thing is still going to turn around. Okay, first of all, okay, let me leave this man and multiply this one first. So I'm going to have 32i minus 2.7j plus 0k is equal to 1.6 times this. So 1.6 times 0.72. So I'm having 1.152 yi, okay, minus 1.1, 1 point what, 152 xj, then plus what, plus 0k, plus 0k. Okay, everybody is being multiplied by 10 raised to power minus 19. So if I compare these two, you are going to see that, permit me to finish it up here. By comparison, you are going to see that, compare this to this, you're going to see that 1.152 yi should be equal to 32i, so that my y will now be 32i divided by 1.152i. So I'm going to have 32 divided by that, my answer. So I'm having my y is 2.27.8. Okay, 27.8 is my y. So compare the next one. If I compare the next one, I'm going to see that minus 1.152 xj is equal to what? My minus 2.7j. Okay, so therefore my x is now 2.7 divided by 1.152. Okay, you have x will take care, j will take care of j, and minus take care of minus. So if you do that, you're going to have 2.7 divided by 1.152. So I'm going to have that this is what, 2.3, 2.3, uh, 2.3. Okay, so now, so if you now see that 0 is equal to 0 here, so therefore my v is now equal to what? My s. What's my s? My x is 2.3i. My y is what? My y is plus 227.8j, then plus 0k. Then everybody should be raised to power. Don't forget this 10 raised to power that's supposed to multiply this thing. So if it is moving to the other side, it will be 10 raised to power 19, not minus 19 again. So that is that. So thank you very much for watching. Please don't forget to like, share, and subscribe. Peace.